In this video, we want to evaluate each inverse trigonometric expression that's given here. So we'll be dealing with the arcsine, the arccosine, the arctangent, and the arcsecant. And those of course are the inverses for the sine function, the cosine function, the tangent function, and the secant function. And their respective ranges and domains are given here. So for the arcsine, there's your definition. The domain is between -1 and 1, including the endpoints there. And the range goes from -π/2 to π/2. For the cosine, there's your definition. That has the same domain as the arcsine, -1 to 1, including the endpoints there. And then the range goes from 0 to π. And then you have the definition for the arctangent. Its domain is all real numbers. And the range goes from -π/2 to π/2, not including -π/2 or π/2. And then you have the definition for secant. There's your domain, -infinity to -1, union 1 to infinity, including the -1 and the 1. And there's your range, from 0 to π, excluding the π/2. So let's look at the first one then. We want the arcsine of -1/2. So that's the same as saying then we have y equal to arcsine of -1/2. So this simply means that I want sine of y both sides here. Tells me that sine of y, take it the sine of this side, gives me a -1/2. So I can write it this way. This, remember, is an angle. That represents an angle. It represents the angle whose sine is -1/2. So I'm looking for an angle that has a sine of -1/2. And this is where you have to be careful here. There's going to be an infinite number of angles that have a value of -1/2, but you have to stay within the range here, which is between -π/2 and π/2. Now we know the sine of π/6 is 1/2, but we need -1/2. So we need to find an angle between -π/2 and π/2 that has a sine of -1/2. Or just make it a -π/6. That's in that interval, and there's only one answer for this one. This is restricted in that interval from -π/2 to π/2. And the next one, we're looking for arccosine of 0. So we want the angle that has a cosine of 0, but it has to be in this range. There's a lot of angles that have a cosine of 0, but we want the one that is between 0 and π, including 0 and π. That's the same thing as saying y is the angle that has a cosine of 0. So if I take the cosine here of y, I have to get 0. But I have to be in the interval from 0 to π. The only angle that satisfies that condition is π/2. Again, arc cosine of 0 is the angle whose cosine is 0. And that would be π/2. Cosine of π/2 equals to 0. And it satisfies the range. Now for the tangent, its domain there. And in this case, the range is from -π/2 to π/2, not including the values of -π/2 and π/2. So the angle has to be between those two values. Again, if I call this y here, I'm looking for an angle y such that tangent of y is equal to the square root of 3, all in the appropriate range. So what angle between -π/2 and π/2 has a tangent of square root of 3? Now you can use degrees here to get the answer, and then just put it in radians. This would be 60 degrees or π/3. So the tangent, this is just saying the tangent of π/3 or 60 degrees is square root of 3. Now the next one deals with secant, arcsecant. So notice here the arcsecant, there's your definition. You have the domain there, and then the range goes from 0 to π. 0 to π, 0 included, π included. Notice the open circle here. The π/2 is not included. So any angle between 0 and π, except π/2, that has a secant of negative the square root of 2. So let's look at this then. And let's say this is a right angle here. say this is a 1, 1, and the square root of 2. That's your 45, 45 right triangle. So if I label this as 45 degrees, and in radians, that's the same thing as pi over 4. And remember, the secant is the opposite. The hypotenuse, I should say, over the value of the adjacent side. But we want it to come out to come out negative. So we want an angle from 0 to pi, except pi over 2. So it could be here, could be over here. Well, you use the 45 degrees as your reference angle. So if I say, okay, let's label this, it's not going to work over here because the answer is going to be positive. The secant of 45 degrees is the square root of 2 over 1. That's positive, but a negative. So if you treat this, if you look at this as your reference angle of pi over 4, then this angle in here is 3 pi over 4. And in that quadrant, the secant is negative. So this was have a value of 3 pi over 4. And this represents the angle whose secant is negative square root of 2. Thanks for watching. We'll see you next time.